from the last class.
Yes, Harsha, you saying something?
Yes, ma'am. I have a doubt in a few questions from the last class.
Which ones, Harsha?
Ma'am, the pulley mass question of acceleration of center of
Do one
mass.
thing, just send its pic on WhatsApp. I'll have the
Okay.
questions then. Okay.
Ma'am, I don't have your number.
You don't have the questions.
No, I don't have your number.
You're not added on the group, Harsha?
Ma'am, let me check. Ma'am, I sent them.
Harsha, you sent the question?
Yes, ma'am. Yes.
Okay. I'll check it once. Yes, class. See, in the last class, we couldn't complete center of mass, right? So let us complete first center of mass. Yes, what was center of mass? See, center of mass is basically that point in a body by which you can replace the entire system by just that single point. No, you don't need to go out into the breakout rooms. Here only you will be having your classes. So, see, what I was saying is center of mass. So, center of mass is that point by which you can replace your entire system and just put that point. So, whatever is the velocity that is occurring, whatever is the acceleration that is occurring, it will keep on occurring for that system. And you will be just calculating it for this same mass. Understood? So, for this mass, particular mass, you have to calculate mass. Then if you have mass, you can calculate acceleration multiplied by mass will give you force. Then you have velocity. All right, so this is all about center of mass. So what all things we had studied? The displacement of center of mass we calculated. So basic formula was mass into separation plus mass into separation plus mass into separation divided by total mass. When you differentiated this, you got velocity m1 v1 plus m2 v2 plus m3 v3 plus m4 v4 like this. Then when you differentiated velocity, you got this m1 a1 plus m2 a2 plus m3 a3 divided by m. Now when you are multiplying mass into acceleration, you are getting force. Fine. This is how you will calculate it. Okay, yes, this is a very important question that I wanted to discuss in the last class, but time wasn't as sufficient, so I couldn't. Please pay attention over here. A man of mass small m stands on a wooden plank of mass capital M, floating on a river near its bank. The man starts walking on the plank towards the left. When the man reaches the end of plank, how much distance has the plank moved? Do one thing, write it down, write this question. Then I'll discuss it. First, write it down, make a rough figure, all of you. At least have an idea what is going in this question. This is a very important question. Mark this as important. Then I'll discuss it. First, try it by yourself. And those who ever get their answers, please text me in the chat column. Martin, I'm audible to you? Martin?
Yeah, ma'am.
Harsha, you're Krishna's sister.
Yes, ma'am.
Oh, okay. See, this question you have sent, this we discussed in the class,
Yes,
and
ma'am. I
both of
didn't.
these questions we discussed, no, Harsha?
Yes, ma'am. I didn't understand a few parts in those questions.
Okay, these two questions you're having doubt.
Yes, ma'am.
Okay. Then I'll discuss it in the class itself because these two questions I did in the class. Fine.
Okay.
Let's discuss it, class. I think much time is sufficient. See, it says that a man of mass M stands on a wooden plank of mass capital M. It means if there is a so man is there, fine. So a mass of this wooden plank, this is capital M. A man of mass small m stands on a wooden plank of mass capital M. What is the mass of man? Small m, and mass of wooden plank is capital M. The man starts walking. So what is the mass? M mass is there. Now the man starts walking towards the end, towards the left, that is towards the end of the plank. How much distance that does the plank has? See here. This is the end. Let me take this as origin. So this becomes x equal to 0. Length of the entire plank, this is L. Now, see, the center of mass, suppose the center of mass of this plank is here. This is the center of mass, fine? This is the center of mass. The man was standing here initially. Man is standing here towards the end. Now the man starts moving towards the left. Fine. Now when the man starts moving towards the left, plank shifts a bit towards the right. It's like this is the plank. Suppose person is here. All right. Now as soon as the person starts moving, he slides away this. It was like this. He then slides away this while walking. So how much distance has been slipped by it? That we have to find out. Suppose, let's say, the plank has moved this much distance. We don't know what distance is this, but this much distance has been moved. Now, one thing that you have to always remember, that mass, the man plus plank system, center of mass will remain this. Fine. How much distance is being changed, that you have to find out. But man plus plank systems mass will remain, center of mass will remain the same. So plank has moved away from here. The person has started. He has started moving towards this end. They slipped towards it. Now this distance was L by 2 for a rod. This I have told you that this becomes center of mass is exactly at the center. So this is L by 2. This is L by 2, right? So look here, class. The center of mass here will also be the same. Center of mass here will also be the same. This was the earlier center of mass. Suppose this is the end. This is the end. Let's say this is the end. Center of mass will remain the same. Let's say this has moved to some distance x, certain distance x. Now see what all things do we require. Now what will be the length? X, and this L by 2, which was already present, this half of it, which was already present, the half of it. This is actually towards the edge. I have not drawn this properly. It should actually be like this. This should be towards the edge. Then only it will be able to make it. All right. Now see, L by 2 and XL is there. So when we have to find out now system center of mass, this was x equal to 0. This is also still x equal to 0. But this separation, I have taken it as x. Suppose this is as x. Now what is my system? Man plus plank. This is the system. All right. So what is mass 1? M1. M1 is small m. That is the mass of man. What is M2? M2 is capital M. That is the mass of the plank. X1. Where was the man? What was X? Means which separation do we have to take from center of mass? From the origin to the center of mass we take. That is L by 2 only. So this also will be L by 2. All right. And when we have to consider X2, this won't be L by 2. This will be complete L. We are taking it from here. No, man is here. Right now the man is here. So complete length will be taken. But when the man has stepped over here, when the man is towards the edge, so center of mass, this was L by 2. Plus X has been there. So X plus L by 2. Initially X2 was C class. Let me write it separately, then this would be clear. Wait. Let me write it initially. I'm talking about everything initial. M1 is mass of man. Where is the man situated from the origin? L distance. So X1 is L. This is initial. Till here, is it clear? Mass of man is M. Separation from the center, from the origin is L. So X1 is L. Mass of plank is capital M. And what would be the separation from the center? You will take the separation of center of mass. That's what is the entire concept of center of mass. So instead of taking the entire plank, so many system of particles are present. I can replace the entire plank by just the center of mass. So X2 will become L by 2. This is the initial case for the first case. First, tell me, is this clear why we are taking this? See, the mass of man is small m. He is at a separation of x equal to L from the origin. So M and L. Mass of plank is capital M. Separation from the origin will be, from which point will you consider separation? From first point, left point, right point, which point? Center of mass, from center of mass. That is the entire purpose of center of mass. And center of mass is separated by L by 2 for symmetrical figures. So this is L by 2. First tell me, this part is clear to all of you?
Yes,
This is clear? Alia, clear to you?
Yes, ma'am.
Okay, good. Now see, when the person has shifted this something, there would be some center of mass formula for this one also, right? What would be the formula? M1 x1, so ml, plus m2 x2, ml by 2, divided by total mass m plus m. Fine. There is a center of mass initially before the man started moving. Now man has started moving, man has reached the end. Fine, the man has reached the end. So plank has displaced a little. So what, everything will be the same. It's just that now the separation, it will be the same. It's just that this additional x has been added. This x separation, everything rest, everything is same. What you have studied in this part. What is the difference that is coming? The difference that is coming is just that this entire separation is not just L by 2 this time, it is L by 2 x plus x. So what will be again? I'm writing M1 will be mass of man. What is the separation of man from the center of from the origin? Man is at the edge, so this is x. So x1 will be x, right? Man is at this edge. M2 mass of plank M. What is now the separation? What is the separation now? L by 2 plus x. So what will be xcm now? This will be mx plus m into L by 2 plus x divided by m plus. See, in our system, center of mass will remain same. So what will happen? This is one equation. This is second equation. Both the equations are actually the same. So what we can do? We can equate both of these. When you equate this, this becomes ml plus m capital X. Capital M L by 2 divided by m by m. Why? Because both the center of mass, these are same. Center of mass won't change. This we discussed also in the last class. And what was the next thing? This was mx plus m L by 2 plus x divided by m plus m. One thing that happens good is that this m plus m gets deleted. Now what are we left with? This is ml plus ml by 2 is equal to mx plus ml by 2 plus mx by 2. ml by 2 will be cancelled. From here we can take x common. That will give us m by m, right? If we take x common from here, this is ml, mx by 2 is there. Okay, mx by 2 is not there. Just mx is there. ml by 2 plus m is fine. So x we can take common, x plus m is equal to ml. Final answer, the center of mass. Now the separation of the plank is ml divided by m plus m. This is our final answer. A very important question and a question that has been repeated a lot. Please note it down. Wherever you people are getting stuck, let me know. Get your doubts clarified in this question.
I finish your question, and
Yes, someone is asking something, Martin.
Yeah, there's a question again.
Yes, Martin.
Can you like show the question?
Yes, yes. Just wait. Hmm. The origin will always be taken as 0. Now see, when you are drawing this is a rough figure that you have drawn, you know that entire length is L. So this line, no, this I have drawn it myself. This is not a part of question. This I have drawn it myself. Why? Because I need a reference line. So you choose a reference line and accordingly you can mark it as origin, mark the origin anywhere. See, this in this question I took it as this because I find it easier to solve it in this way because to avoid minus. If I take the origin like this, then this part will become minus L by 2. So same answer you will get, but it's just that minus sign and everything will come. So origin you can take from anywhere. Anywhere, just take try to take it near the baseline, and then anything that is coming here towards the right side, that will become positive, and anything that is towards the left side, that will be negative. So just make origin the rough line by yourself, the axis, the y-axis. Okay, Arsha?
Okay.
Yes, Harsha. See, center of mass doesn't change until and unless you have external force acting in your system. Right now, what is our system? Man plus Planck. That's what I was specifying initially. So if there is external force occurring, then we cannot solve the question in this manner. Since we know nothing is occurring, it's just the movement of the man, no external forces acting in our system. That's why the center of mass is. All right. Otherwise, center of mass would have moved.
Okay.
See, in conservation of center of mass is momentum, conservation of momentum of center of mass. F external will now be, see, dp over dt we write, rate of change of momentum we write. So dp, when we are talking about the momentum of center of mass, so F external, we'll use this formula only. But see again, class, one thing, isolated system I had mentioned you earlier also. Isolated system means a system where your external force, this becomes 0. So this will be PCM over dt, this is equal to 0. So momentum, see, if rate of change of momentum becomes 0, so what is momentum? Something is not changing, then only its difference will be 0. When final minus initial is same, then only we say something is 0. Final velocity minus initial velocity is 0. It means velocity didn't change. So this shows what? This shows that the center of mass is constant. Momentum of center of mass, this remains constant. This question says that, see, if a child jumps off the car towards right with a velocity u with respect to ground, find the velocity of the car after the jump. So see, you will apply conservation of momentum here only. Final momentum center of mass will be mass into initial velocity minus mass into final velocity. Yes. So initial is equal to final. That's what we have studied. Momentum will remain constant when you're talking about center of mass. So mu is equal to capital M, let's write, to differentiate the mass of car and mass of the kid. So this becomes m into this. Actually, both are equal. V, so velocity will be mu divided by basic question. Now we'll start with a new topic, kinematics of circular motion. This we didn't do, but this is very easy. Now you will find it very easy to do once you have done motion in a straight line. Note it down, then we'll start with that. This is an isolated system. See, no external, whenever no external force is occurring, no. Suppose sometime in most of the questions, external force is written itself only. Otherwise, you will also notice a force that is not produced by the system. See, normal reaction will be there. If the child is standing on the car, is sitting in the car, normal reaction will be there, gravitational force will be there. So these are all the internal forces. Some external force is occurring, means out of these two. That's how you have to identify.
Okay.
See, in kinematics of circular motion, whatever you have studied already in your motion in a straight line, same things will be repeated. Same formulas you have, you just have to remember their analogs. Though these analogs we have already discussed in laws of motion, after laws of motion, circular motion we did separately, that time we have discussed it. For linear displacement, you have angular displacement. Theta, remember we did theta, the angle that is swept. For initial velocity, see, velocities are angular velocity omega. So if it is initial velocity, we use initial angular velocity represented as omega naught. If it is final angular velocity, we simply use the symbol omega. Then we have acceleration. Remember angular acceleration, tangential acceleration, so many accelerations we have done it. So this is the angular acceleration, which is exactly just the analog of it. So how to remember those equations? Now, you have these equations. V is equal to U plus AT. See, here it will become V is omega. Initial velocity is omega naught plus alpha, time will be the same. Then we have S is equal to UT plus half AT square. Displacement is theta is equal to omega naught T plus half alpha T square. V square minus U square is equal to 2AS. So omega square minus omega naught square is equal to 2 alpha theta. Like this you have to. Now see, we didn't do the derivation when we were discussing the first lesson also. So the same derivation it is. So we'll do here the derivation. Whatever we are studying here, just to make the analogous term for the linear one also. First note this down, then we'll discuss each derivation of these. See, when we have to derive omega is equal to omega naught plus alpha t. We already know what is alpha. Alpha is d omega over dt. So if we have to find out d omega, means from initial value to its final value, we'll integrate alpha dt from 0 to t, right? Now, let's integrate this. So this becomes omega, values from omega naught to omega. Alpha integration dt 0 to t. So this becomes omega minus omega naught is equal to alpha t from 0 to t. So this is equal to omega minus omega naught is equal to alpha t minus 0. So we have equation omega is equal to omega naught plus alpha t. Same derivation class v is equal to u plus at for your linear ones also. Second one also let us complete it itself. Theta is equal to omega t plus half alpha t square. Now see omega, we'll start with omega. Omega is what? D theta. Just remember the first steps and you will be able to manage in all these questions. So omega dt. Omega dt will be from integrated from 0 to t. And then you have d theta. Theta you are integrating it from 0 to theta.
Ma'am, but we have two variables, right? V,
Yes?
W, and T. We have two variables, right?
Yeah, there are two variables. See, omega and dt you're talking about.
Yes, ma'am.
See, this omega's value we already have now. This value of omega, no, this is omega naught plus alpha t we already have. So now what we can write, we can resubstitute this. So the problem that you are mentioning, that is now solved because we already, now we have derived no, from the first equation, this we have now. So,
Ma'am, so in the previous equation, how do we do it if we have two variables?
here you are saying something.
Yes, ma'am. Alpha and T.
Alpha dt, alpha is a constant. It's acceleration, no, angular acceleration.
Okay.
Okay, and acceleration is constant. See, in all these equations, what were these equations? Remember when we did it? These were uniformly accelerated equations of motion. Uniform acceleration. So it means that we are having acceleration is already constant. Otherwise, we wouldn't be able to solve the question. That is, you are pointing correctly. But the issue is here that we have acceleration. Otherwise, these equations aren't valid if your acceleration is changing. So
Okay.
let's put it in the value. So this will actually become, first it would become omega naught dt plus then this alpha t dt from 0 to t. Now see that constant and the variable problem has been now solved. And we are already integrating d theta from 0 to theta. So this becomes omega naught t values from 0 to t. Alpha is common. This becomes t square divided by 2 from 0 to t. And this is theta from 0 to theta.
Ma'am, so omega naught will be a constant?
Omega naught will be constant. See, here we are taking time only as the variable quantity. Omega, acceleration, all these things are constant in our equations. Constant as in, you can say the variation that is occurring in these equations, that the variations we are taking, the variations is negligible. Because the change that we are talking in terms of time. And more importantly, we are not taking omega that is changing with respect to second. See, initial value of, let's say, car is, let's say, 2 meters per second. So you always take it as 2 meters per second, no? It can happen that the velocity changes and it finally becomes to 5 meters per second. That's why we have separate variables for initial velocity and final velocity. Because velocity will change. But when we're talking about initial aspect, only this part will be there. When we're talking about final aspect, only you will consider this. So right now for the calculation, 2 meters per second will be constant for you. Got it?
Yes, ma'am.
Yes, so this becomes omega naught t minus 0 plus alpha by 2 t square minus 0 square is equal to theta minus 0. We have our equation already. So this equation becomes theta is equal to omega naught t plus half alpha t square. This is the equation. Third one. To prove omega square minus omega naught square is equal to 2 alpha theta. All the questions are similar to what you have already studied. That's why I took circular motion separately before starting. Please revise circular motion class. See, alpha is d omega over dt. If I multiply and divide something by the same quantity, this would be cancelled. That will give me 1. It means I can do this. Now class, tell me one thing. D theta over dt. Is this something? D theta over dt? Can you relate it with something? D theta over dt. What is it? Angular velocity. It is actually angular velocity. Omega is d theta over dt. Yes, right. This is d theta over dt. Now see, it means this is omega. So what is alpha? Alpha is omega d omega over d theta, right? Now let us just shift it there. Alpha d theta is omega d omega. Now see the variables which are considering here. We are integrating this from omega naught to omega and displacement from 0 to theta, the way we have been doing it in previous question. Now angular acceleration, this alpha will be constant. This becomes theta minus 0. This is omega square by 2 from omega naught to omega. So alpha theta, 2 alpha theta is equal to omega square minus omega naught square. This is the equation. This is how to prove all the equations. Okay, note it down.
Ma'am, can you scroll up? Done, ma'am.
Just Harsha, just you stay. Others, if you people have completed, you can start leaving.
Thank you, ma'am.
You had a doubt in this question, no, Harsha?
Yes, ma'am.
See, we have to find out acceleration of center of mass. So basic formula is m1a1 plus m2a2 divided by m1 plus a1. Now see, we didn't have, this part must be clear to you. This is very easy. It's just that in this question, it has specified take the upwards acceleration as negative, downwards acceleration as positive. So formula for acceleration when you have pulley mass system, it's net unbalanced force means, or you can make free body diagrams also if you want. Like 5G minus tension is equal to 5A. Here you can take 10G minus tension is equal to 10A and solve these two equations. You getting me? See, you can take free body diagrams also. Up wherever is the acceleration occurring, acceleration is occurring upwards. So tension minus 5G will be equal to 5A. Here acceleration is acting downward. So 10G minus tension will be equal to 10A. Using these two equations, you can get the value of acceleration. Now see here, net unbalanced, what it is given once you have the value of A.
Ma'am, how did we get 5A and 10A? Like, available.
5A is mass into acceleration. See, what is force? Force is mass into acceleration. Force will be mass, that is 5, into acceleration. And what is the net force? Tension must be acting. So tension minus 50, that is 5G. Clear?
Yes, ma'am.
So you have two equations, so you will get the value of A. So in the question, it is saying acceleration, both the accelerations are same. It's just that upwards, this acceleration is negative, this one is positive. It's just the quick condition that is given by the question. So you have now both the values of acceleration minus G by 3 and plus G by 3, right? So just put it in this formula, you will get it as G by 9. Clear?
Yes, ma'am.
One more question you had a doubt in that disk removing one, no? This one, no?
Yes, ma'am. About how we got x1 as 0.
Yes, what was your doubt? How we got
x1 as 0.
x1 as 0? See, this is the same doubt that you were asking. You have to take origin from somewhere. I have taken this as origin. Otherwise, from where will I calculate the center of mass? Center of mass is not just a point that is present. No, it is with reference to something. You also know that a center of mass is what? This is located at a point. It's just a point. So for markings, you have to have origin. It's just that I have taken this as the baseline. Now, anything that will lie here will become minus R for me. From to this distance, this will become R by 2. Otherwise, how will I consider this? It could be R plus R by 2. It could just be R by 2. So should I take R plus R by 2 or should I just take R by 2? There has to be some reference line. So this is the reference lines which I have taken. Now this is like my axis. These are all my axes. Got it?
Yes, ma'am.
So that's
Ma'am,
how.
so the center of mass need not be the origin, right?
Yes, sorry.
Ma'am, the center of mass need not be the origin, right?
No,
It
no,
can
no,
be
no,
anyone.
not at all.